Good morning, everyone. We're just waiting for a few more participants to join us, and just hang on for a few minutes, and we'll get started in about 2 minutes. Good morning, everyone. We're just waiting for a few more participants to join us. We'll be back with you in approximately 1 minute. Good morning, everyone. This is David Rott with Tessman Company, General Manager. Thank you for joining us on our webinar on Turface. Today, we welcome Jeff with Profile Products, and he's going to lead us through our webinar on how using Turface when mixed with your soil will help with playability on turf, leading to less injury for athletes and children. This will include lawns, athletic fields, landscaping, and golf. Please feel free to ask questions by typing them in on the Q&A icon at the bottom of the page. And now, Jeff Langer.
Thanks so much, Dave. It's a pleasure to be with everybody today. Thank you for joining. I will preface this by saying I'm about 1 week removed from a bout with bronchitis, so I'm getting over it, but I apologize if the voice is a little shaky, but we'll get through this, and I'm happy to be with everybody today to share some education and updates from Turface Athletics. I work as the business manager for Turface Athletics for both our sports field and our golf division. I've been with the company for about 13 years, and it's been my pleasure to be involved with a number of industry presentations, field day events, and consultations over my tenure with the company. We certainly always enjoy the opportunity to do webinars and different presentations to groups like this, focusing not just on our products, but on industry education and solutions that can benefit you all in your day-to-day roles and responsibilities. We're with Tessman Seed as one of our great distributors, and so we appreciate that invitation today to speak with all of you. Turface Athletics, for those of you who don't know, we've been in the sports field industry now for more than 50 years. We started as a company making infield conditioners and drying agents, and for more than 50 years, we've really put field safety and playability as the hallmark of what we try to do as a company. And throughout that tenure, we've always had a very strong commitment to education as well. And so we look at ways to share product information, best practice solutions for customers all around the country and frankly, all around the world. So I'm excited today to share some of what we share with customers throughout the industry. not just on infield maintenance, but on turf grass management, and as Dave said, landscape soils, high traffic areas, event areas. We'll cover all of that here over the next 30 minutes. Just to give a little overview of the company, we are a subsidiary of Profile Products LLC. Profile as a parent company, very focused on green space, management of soils, water management, and vegetative establishment. And that certainly includes our sports field group as well. We have a number of products really focused on sustainable solutions across market segments, and we're a leader in research and testing, product development, industry support, education, and partnerships. And so what we try to do is bring solutions across the green industry, and you see a number of our market segments everywhere from golf to sports pitches to landscape applications. Again, many of you may be familiar with Turface Athletics, our sports field division, our landscape division, our golf division, and our erosion control division. So the solutions we'll talk about today are primarily focused on those first two, the sports and landscape market. Our Turface brands have been used, as I said, for more than 50 years, and we service everything from a recreation market all the way up to the professional leagues, including Major League Baseball, the NFL, and Major League Soccer. Regardless of the level of play, our focus is always on safety first. We look at how to make fields, how to make residential areas, how to make playing surfaces safe for athletes. Anybody who's ever managed a baseball field understands that rain is one of the biggest challenges we all run into in field management. A clay-based infield mix that gets too wet is going to be unplayable because it gets slippery, it gets slimy, and you get rained out. And we've certainly seen plenty of that up in the upper Midwest this spring. I think many of you have probably seen something similar to this too, and are familiar with what happens when water pools in the middle of an infield, when things aren't graded correctly, when a mix doesn't drain well. So a lot of what we do is try to offer solutions for water management. Similarly, when an infield is dry, it gets hard, it cracks, it becomes like concrete, it becomes unsafe as well. So we try to mitigate those circumstances and manage moisture on skinned infields for baseball and softball. Just touching briefly on the infield side, and then we'll move to turf grass applications, but there's a real narrow window to be successful as a field manager when you're managing infields. And if you have a field that's high in clay content, you have slippery conditions when rain comes, you have hard infields when things dry out. Those are the photos we just saw. And so at the recreational level especially, we encourage people to look at high sand content infields, which have a lot of good forgiveness from a maintenance standpoint, but we know that high sand content soils drain well, but they can become very loose and very shifty if not managed properly, if they're not maintained properly. So to help balance these high clay content fields with these high sand content fields, we offer soil conditioners that keep those fields safe and playable. And our primary goal is to prevent rainouts, especially in baseball and softball. We want to have a firmness to the field without it getting too hard. We want to manage moisture without it getting wet and sticky. We want to develop a deep reservoir of moisture in an infield mix, absorb the excess moisture, and add a top dressing layer for some forgiveness for sliding surface and to allow a protective barrier between cleats and clay when it rains especially. So all of those principles that we focus on for skinned infields apply when we talk about turf grass management as well. So the products we've been making for more than 50 years are not just for infields, they're not just for baseball and softball. There's a lot of applicability when we talk about turf grass as well. And this probably goes without saying, but the key to a good growing environment is to have good soil. And that's true whether we're talking about a native soil turf grass application, sand-based root zones that you might commonly see on golf courses and professional turf grass facilities, landscape applications, gardens, residential lawns, potted soils. The same principle is always there, that we're trying to improve the soil to provide the best growing conditions possible. So the soil conditioners and the amendments that we've sold into baseball and softball for many, many years has also gained traction in those turf grass applications, allowing plants, whether it's a turf grass plant, a flower, or a vegetable garden, we're allowing those plants to thrive. Just a quick step back to a little science lesson and some plant biology. We know that in order for a plant to survive, it needs CO2 and sunlight, which it's going to get naturally from the air and from its environment. But all of the other things that go into plant growth come from the soil itself. And a lot of times we focus on the role of water and moisture management in a soil. We certainly talk about fertilization and nutrient retention and all of those inputs that go into the soil. But a lot of times what we lose sight of is the value and the importance of oxygen in a turf grass soil or a root zone mix. Oxygen becomes the key to having a thriving turf grass plant. And so we'll focus here a lot on the role of oxygen and how the Turface porous ceramic particles can help promote better oxygen within the root zone. Again, kind of science 101 or plant biology 101, that when we talk about ideal soils, when we talk about textbook soils, we want to really have a balance between solids and we want a balance between air and water. If we have that, if we start with an ideal or a textbook soil, we're going to have good moisture levels in the root zone. We're going to drain well. We'll have high level of soil oxygen because of that 25% air that you see there in the chart. That will resist compaction. It'll have a positive nutrient exchange through the cation exchange capacity, and it will be a sustainable soil. This is an ideal soil in which a turf grass plant can thrive. The problem, as we all know, is that soils become compacted, especially when we're talking about turf grass. The amount of traffic that we put on fields out there, whether it's football, marching band, soccer, lacrosse, even a residential home lawn with kids, dogs, people running around, it's going to compact that soil. And when that happens, the solid space gets tighter and tighter, the airspace diminishes. Now the water holding improves. We sometimes see much greater water levels in soils like that, but we start to lose oxygen. And if we agree that oxygen is the critical component to a thriving soil, that's the one thing we can't afford to lose. So as soils become compacted, we not only lose that oxygen space, but our roots have nowhere to go. Our plant vigor is diminished, and our turf grass plants, our potted plants, our vegetable plants die off because of that. So we look at different ways to improve our soil structure through the use of amendments. And there are a number of options out there, including topsoil, compost, peat moss, which is very common, especially in root zone mixes and engineered mixes. And we have sand, which is often used as a top dressing, especially on athletic fields. So what we'll focus on today is the role of the inorganic amendments as an alternative to some of those common amendments that can improve soil structure. Inorganic amendments do this a number of different ways. We can physically improve our soils in the midst of construction or renovation, or through our maintenance practices to create a better growing environment. The inorganic amendments, specifically the porous ceramic products that we're going to talk about today, help to prevent soil compaction. They help to manage moisture, just like we talked about on baseball and softball fields. They can conserve water, provide for better infiltration and drainage, better moisture management deep in the soil, and then they have the added benefit of increasing the oxygen within the root zone and increasing the cation exchange capacity of the soil, so that as we add nutrients to the plants, there's a positive exchange and those plants are getting the maximum benefit from our fertilization. When we speak specifically about the porous ceramic particles from Profile and from Turface, we're talking about an inorganic amendment that improves moisture, nutrient retention, infiltration, and air of the root zone. We have three components in our mineralogy for the Profile porous ceramics. Those are illite clay. The clay provides the cation exchange capacity to hold nutrients. Opal CT, which offers the air and water porosity within the particle. And quartz is the mineral that gives the particle durability and stability. So when we look at our inorganic amendments and when we look at porous ceramic particles, we're offering a permanent, long-lasting solution when it's incorporated into a root zone mix or landscape soil. You see here the range of different particles that we have. All of these are manufactured in the same way, where a clay-based mineral is processed through a rotary kiln. So we are firing clay at about 1200 degrees. until that mineral converts over to an illite and becomes a permanent porous ceramic particle. Once that process is done, we go through a screening process to offer different particle sizes depending on the market that we are serving. What you see on your screen from left to right is the Profile Greens grade, which is our USGA approved sand-sized particle for sand-based root zones and golf course root zone mixes. Our Field and Fairway is the more common particle size for native soil applications. So soccer fields, turf grass plants, the Field and Fairway is going to be ideally sized to work its way through the turf grass canopy and get down into the soil. Our Pro League and Turface MVP sized particles are most commonly used for baseball and softball applications for infield skin conditioning. And then our Profile Lawn and Landscape is a more coarse particle that's used to amend soils in lawns, gardens, beds, containers, etc. And you'll see the similarities in size between the lawn and the landscape product and the Turface MVP. So when we talk about homeowners, when we talk about residential application, we talk about landscapes later, we'll really focus on the coarse products. When we talk about turf grass amendments, when we talk golf course root zones, when we talk about top dressing products, we'll use the Greens grade and the Field and Fairway, the finer particles. I mentioned the porous ceramic process. For us to get our product into a porous ceramic, we fire it in that rotary kiln, converting it from a clay into the porous ceramic. Every particle has 74% internal porosity, and it's a blend and balance of air space and water space within the particle. Only 26% of every particle is going to be a solid space. So what we're doing when we introduce this into a turf grass application, into a root zone, is adding permanent air and water space into that root zone mix. Because it's a clay-based mineral, we still have a high cation exchange capacity of 33. So to some degree, it's going to act in the same way an organic product would, in that it's going to promote that nutrient retention, it's going to hold on to that fertilizer, and it's going to offer something of value to the plant. But we're also helping to increase water infiltration and distribute moisture throughout the root zone mix. The reason we've been so successful with these particles in baseball and softball is the ability for a particle to hold 90% of its weight in water. That absorptive quality of the particle is great for skinned infields, but it's also great for turf grass applications, whether it's on the surface or in the root zone mix. Most importantly, because it works like a sponge to hold and release water, it will delay the onset of drought stress and also increase the time between irrigation cycles for more efficient water management. With any soil, when we try to modify soils, we're trying to open up and add more pore space. This goes back to the idea of oxygen throughout the root zone mix. It's the reason that we aerify. We pull cores to try to relieve some of that compaction and open up airspace in a soil. Ideally, our root zone mix is going to look something like this, where we have sand particles or soil particles interspersed with profile ceramics or some kind of inorganic amendment, where we will have voids in between the particles to offer airspace. And as you remember, the profile porous ceramic has air inside of the particle too. So when we amend a soil and introduce our porous ceramic particles, we're immediately improving the airspace and the room through which roots can grow. We see more and more people, especially at higher levels of play, moving towards sand-based root zones, whether through construction or through a sand cap process during renovation. Sand-based root zones are becoming increasingly popular because they resist compaction and because they drain well. The problem with sand-based root zones is they don't compact, they lack moisture that's going to be plant available, and they also lack the nutrient retention. It's a big part of the reason that people will add either compost or peat into a sand-based root zone. The problem with those amendments is that they fill those void spaces in between the sand particles, and over time, the peat, the compost, the organic matter begins to decompose and degrade, and it starts to create layering, and it starts to create a compacted substrate, which again prohibits then the growth of rooting. So our goal with the porous ceramics is to improve the root zone's air and water balance, air holding, water holding capacity, and nutrient holding. And we do that through the introduction of profile porous ceramics. We'll get into a couple examples here just to show some of the differences, both from a lab test and from some plot trials that we've done in the past. You see on the far left side, and this is starting with a sand-based root zone, on the far left is the introduction of 15% porous ceramic as an amendment to a sand-based mix. In the middle, you see 100% sand, and on the far right, you see the introduction of 15% peat. And this illustrates what I said earlier, that the porous ceramic will provide a continued balance of air and water space inside that root zone mix. With 100% sand, we know we maintain a lot of airspace. There's plenty of room for roots to grow within the sand, but we sacrifice the water holding capacity and we sacrifice nutrient exchange. With peat, we gain the benefit of nutrient exchange, and it will hold a significant amount of water, especially over time as it breaks down, but we're sacrificing increasingly the airspace when we introduce peat into a mix. Now, when we talk native soils, this is what a normal Bermudagrass, and I know we don't see a lot of that up north, but these were some trials we did down in South Carolina, where we introduced profile porous ceramics into some native soil applications. So here's the rooting with normal native soil with no amendments. We see on the left the introduction of 50% sand to the native soil, so we get longer roots, but we don't have the density. On the right, we add 20% of a porous ceramic, or a Turface particle in this case, to the native soil. We not only get the longer root hairs and fibers, but we get much more density to that root mass. Now we have something that can start to withstand the traffic that we consistently put on our fields day in and day out. You see this illustrated in a lab test as well. What you see on the very top line is the data from a 100% sand mix, the drainage or the infiltration rate at 14.6 inches per hour. Total porosity in that 100% sand mix is 39%, and water retention at field capacity is 10.7%. We took this sand-based root zone and we introduced profile at a 15% rate and at a 20% rate. You not only see an increase of drainage, which almost seems counterintuitive that anything could drain faster than sand, but when our particles reach full saturation or reach capacity, they promote increased drainage and they drain at a rate faster than sand. So we have an increase here in our hydraulic conductivity. We have an increase in our porosity, both in our air porosity and in our capillary, our water holding capacity. So our porosity with 20% profile goes up to 46% from 39%. Our water retention goes from 10.7% all the way up to 15.4%. So you see we've increased air porosity almost 11%. We've increased our water porosity 26%, and we still promote positive drainage and have increased that by 35%. This gives us a much better root zone performance over time, and it certainly contrasts very nicely to a peat or a compost amendment, which would push the air-filled capillary pore space down. It would drive the water retention up, but we lose a lot of this porosity and a lot of this drainage that we want out of a root zone mix. I mentioned earlier the ability of the profile porous ceramics to also delay drought stress. These are research trials at Ohio State University, computer modeling that looked at a 100% sand mix, a sand and sphagnum peat blend, and a sand profile blend. And they looked at turf stress as a measurement and looked at 12% as being the threshold at which drought stress would be visible by the naked eye. And we see that after a rainfall, we can go 3 or 4 days with the sand peat, and the sand profile and still minimize and reduce our drought stress. But on the 5th day, we start to see the droughty conditions of the sand escalate to the point where there would be visible drought stress on the turfgrass plant. By day 6, we see the sand peat mix in the same situation, but the profile, because it has retained so much moisture from that initial rainfall, gets to the 8th day before that turfgrass stress is visible. So by introducing the porous ceramic amendment, not only do we give ourselves the benefit of holding water and give ourselves the benefit of the drainage, but we have a slow release curve that allows that turfgrass plant to remain healthy for longer, and we reduce our drought stress as a result. I mentioned earlier the different particle sizes. Just to illustrate this again, when we talk about turf applications, we talk about landscape applications. We have our smaller greens grade particles. We have a medium fine field and fairway particle, and then a medium coarse lawn and landscape particle. And this is going to be similar to the Turface MVP that many of you may be familiar with. So again, talking sand-based root zones, and then we'll go back to native soils and managing some of the high traffic areas that are probably more common, especially at the recreational level and in school districts. But from a sand-based root zone, we're addressing some of the common issues that you see out there, whether it's excessive thatch in a layer at the top as organics start to break down, improper top dressing or inconsistent top dressing, and a lot of these principles apply to native soil fields as well. If you're going out, you're seeing layers near the surface. If you have an inconsistent top dressing program, some years you've done it, some years you haven't, maybe you've changed the materials over time, you'll see these layers start to build up from improper top dressing. Black layer, very common, especially on golf course root zone mixes and golf greens. Just pure compaction layers and how you start to see that separation between the good mix near the bottom and the contaminated mix near the top. It makes it impossible for water to infiltrate its way down and work its way through the base to the substrate. A sod layer, which is very common, especially following new construction or renovation. So these are just a couple to illustrate, because we've done this both on native soil and sand-based, that the applicability and the properties remain the same. This is Olivet, Nazarene, where the Bears have their spring training facility. They did a renovation back in 2007. Where they completely stripped the sod. They rototilled porous ceramics into the mix, graded it, and resodded. They have not had to go back and do any amendment or resodding since. Their cultural practices and top dressing program has been enough to sustain this, where they haven't had to do major renovation work or major fixes. So they're getting a 12-year life cycle out of that root zone mix because of their amendment and then because of the cultural practices they continue to employ. They applied the same principle to their sand-based root zones at Halas Hall. They constructed their third field at that facility last year, and that was done as a blend of sand and profile porous ceramics. Similarly, for the last 9 years now, they've been able to use the exact same mix and the same sod without having to renovate or replace. So there are certainly long-term benefits that you see through the introduction of good inorganic amendments. Soldier Field also commonly uses our material. And that's one where they put a lot of traffic and a lot of events because it's a city-owned field. So you tend to see some of the damage more at Soldier Field than you will at Halas Hall or Olivet Nazarene, simply because of the amount of traffic. Again, it's a sand profile mix. Cultural practices are similar, but they have to be far more aggressive just because of the traffic that's put out on that facility. So when we talk about native soil specifically, our soccer pitches, our football fields, lacrosse fields, our event areas, high traffic areas, the principles for managing these are going to remain the same. That with the porous ceramics, we have several ways that we can try to stay out ahead of issues, and we can recover from issues when we do get rain and we do get damage, especially from foot traffic. One of the best things we can do is go out preventatively with a top dressing prior to rain to help protect our turf grass plant and help protect especially worn areas of the field. During rains, we can go out and put an inorganic amendment down to absorb the excess moisture that's coming onto that field. And then following rains, and especially after damage, when we overseed or especially reseed areas that have been damaged, the profile ceramics will help manage the moisture. They'll help reintroduce that plant growth and provide a better growing environment for that reseeding. Remember, we talked a little bit about the water management before, just to illustrate what this means in terms of the overall water absorption and water holding capacity. If the particles hold 93% of their weight in water, that gives us the ability for every 50-pound bag to absorb and hold 46.5 pounds of water, which is going to be just over 8 gallons. So that means a 50-pound bag is going to be 5.57 gallons of water that's going to be held within the particles and then slowly released into the plant as it needs it. That reservoir not only helps us rescue our turf grass and our root zone mix from rains, but it holds that water and releases it over time as the turf grass and as the root zone mix starts to dry out. When we talk about turf repair, it goes back to the very first principle I illustrated, which is that safety and playability is the first thing we should be focused on as turf grass managers. We want to prevent hazardous conditions and turf damage, which we can do with the field and fairway product, especially if we can get it out in a preventative application. We want to promote turf recovery. We don't want to let those damaged areas become worse as the season goes on. So being able to come out and repair areas following a game or following an event is going to help, especially when added with a mulching granule or some kind of a cover, and then a starter fertilizer, and that will help promote the ideal growing conditions so that we can reestablish a grass plant. These worn areas, as we know, we've all seen them, they become a significant risk. Something on a warm, sunny day doesn't look like it's going to be a dangerous condition, but as soon as rains come, that worn area will quickly become mud, especially in front of a goal mouth. A little bit of rain, in addition to the foot traffic, makes the surface unsafe. Not only do we ruin the grass plant on the surface and start to shear off some of the grass, but we're then further damaging the soils because we're going to increase that compaction. As we push water down in there and we increase our cleat traffic, we're going to start to compact that root zone mix further. So one of the best things we can do is a rescue application of field and fairway. What you actually see here is our Turface Pro League product, which is an alternative as well being poured out there. We recommend the field and fairway because it's a little bit finer. It works its way down better into that turf canopy. We're going to absorb the excess water, but we're also going to provide a surface layer that now protects the grass plant as that game goes on. And as I mentioned, when we go to prepare the soil for seed establishment, we now have introduced a little bit better of a growing media that's going to help that seed germinate. Raking the field and fairway into the top ½ inch gives us a seed bed. Any compacted soil that we can rake up to start to soften that environment and loosen it a little will help as well. Once we seed and fertilize and put a cover on that, we'll be able to go ahead and get grass growing again. Couple options to rejuvenate your worn out sports fields. Aerification, obviously a big one, and we continue to preach that. If nothing else, by aerifying, you're introducing some oxygen to the root zone and you're removing some of the compacted soil. Top dressing with a layer of field and fairway, especially on native soils, will help because as those particles get dragged into the holes, you're now adding those porous ceramic particles down into the root zone mix, which is really what we want to do, is get it down into that growing environment. And then we can seed and fertilize once again to reestablish our grass plants. There are other methods as well that include DryJect, drill and fill, plenty of ways to try to get amendments down into the soil, but that's really the most important thing we can do is introduce that oxygen back into the root zone after we've compacted our areas. So when we get those rains and we go out and pour product and rake, we've got instant footing that we're now giving our athletes for the sake of safety and playability. So I want to talk just for a few minutes as well, and then we'll wrap up, but I want to cover the additional areas in which our porous ceramic particles can be used. So we've talked a lot about turf grass root zones. The same principles apply in those high traffic event areas, including concession stands, walk-up areas, sidelines, even outdoor weddings. So if you're managing a park facility or you're managing a hotel facility that's going to host high visibility, high traffic events, consider these applications of the porous ceramic particles, not just to prevent damage, but to help regrowth afterwards as well. I mentioned earlier garden soils, hanging baskets, landscape beds, a wonderful backfill for trees, shrubs, ornamental plantings. This was a high traffic event area down in Atlanta, Centennial Olympic Park, a concert ground, a public space that's open year round, tons of foot traffic, tons of compaction, and because of that, they're constantly fighting standing water, muddy conditions, and a big problem with damage when they have their annual concert every April. So what they did, and you see two sections here, it sloped on a hill and all the water tends to run down and pool. They ended up going through and doing a sand cap to try to fix the native soil issues that they were having. So we had a 6-inch sand cap with profile porous ceramics that was introduced into one area as a test plot. They left the area with native soil down below, poor drainage, all the water pools there. The sand cap allowed them to successfully manage this area and not just prevent the damage, but they promoted better regrowth as well. We see similar applications in backyards when dog runs or kids are running around, muddy conditions, especially after winter thaw, especially when we get the heavy rains of the spring. Here we did a preventative application of the Turface particles prior to seeding. We used our cover grow mulching granules with the seed and fertilizer, and we started to see revegetation 3 weeks after seeding. Now we've promoted an area that has grass established. The porous ceramics are still in that mix to help reduce the compaction and promote oxygen in the root zone. And now we've given a much better environment for the kids, for the dogs, etc. in this backyard application. So that's an example of a reseeding, and that's a kind of a small renovation. We see these on larger scales too with lawn establishments, new lawns, new renovations, or large renovation projects. We've done everything from growing media with the NASA space station to rice trials at Purdue University, growing in 100% porous ceramics. We talked a lot about sand-based and native soils, but you can use it as a growing media as well with 100% porous ceramics. These are some of the trials we completed at Purdue University. And again, they did some different plots that showed 50% rates of Turface, and we had some controls and some different mixes as well, including some sun grow and some easy growing media, and the Turface particles helped these mixes really thrive. We talk rates just briefly, and really 50-pound bag of Turface or the porous ceramics can go a long way when we're talking flower beds and gardens. So this doesn't have to be thousands and thousands of pounds. When we talk about lawn establishment, we get into some of those rates. You see there, we recommend anywhere from 2,000 pounds to 2,500 pounds if we're doing a full amendment of a heavy clay soil. So when we get into those situations where we want to introduce 30% of the porous ceramics, we get into some pretty high rates. When we're talking flower beds, hanging plants, potted soils, etc., those rates come down because you're covering a pretty small area. We mentioned backfilling around individual planting as well. For a 1-gallon plant, 7 pounds of Turface or porous ceramics. For a 5-gallon plant, less than a 50-pound bag will help to break up that soil. Just to illustrate, I think we're all familiar up in the upper Midwest with some of the heavy clay soils that get thick, that get really difficult to break up if you're working in a backyard or a landscape application. Introducing the ceramics, and here we're doing that at a rate of about 30%, help to make those soils a little bit more friable. You'll see here, if the video plays on the screen, that using that porous ceramic starts to break up some of the big chunks of clay that we commonly see in those compacted soils. So it makes clay soils a little bit more workable, a little easier to manipulate. Those soils can then be taken and added into those planter beds. And we're now putting that permanent airspace into the soils. Established lawns are going to be treated very similar to the sports turf applications, where we're going to go out and try to amend. If we can core Aerify twice a year, that's ideal, and we can go back out with the Turface or the porous ceramics at 15 bags per 1,000 square feet. Again, that's going to get us a rate of about 20 to 25% of the porous ceramics down into the aerification holes, and now we're going to start to modify that soil and start to amend the soil that we have. The result of that, more moisture distribution, better drainage, nutrient retention. Probably most important is the reduction of the compaction, and that's what, again, is going to give us that stronger and healthier turf. New lawns, a more aggressive rate because we have the opportunity to go and rototill Turface down into the top 4 inches. We look at a 1 ton per 1,000 rate. Again, that's just based on getting about 30% of the porous ceramics into the mix by volume. We'll finish here with a homeowner project that we did. This was up in the Pacific Northwest. This was about that 1 ton per 1,000 rate, bags spread evenly across the backyard, rototilled into a depth 3 to 4 inches, rolled tightly prior to seeding, and then when the seed was put down, we also topped it with our mulching granules to cover grow. Just to give it some cover, that gives it a little bit of protection so that you don't have seed migration. It reduces a little bit of the risk that you're going to have birds come and grab the seed. We're going to water this, and it's going to start to expand. These pellets will then cover the seed. They started to see germination in about 7 to 10 days. About 2 weeks after, we had some pretty significant plant growth coming through. And 4 weeks after, 5 weeks after, they started to really see good coverage This was about 8 weeks after that we did this picture, and we show the establishment now of a new lawn. So these are the principles that, again, whether you're managing small areas, high traffic areas, goal mouths, sideline areas, areas between the hashes of a football field, or you're working in landscape soils, planter beds, backyard applications, high traffic events, the same concept applies that if we can introduce some kind of a porous ceramic amendment, whether it's the greens grade, the field and fairway, or the lawn and landscape product, we're going to improve our soil structure, add oxygen into that mix, have better drainage and moisture retention, and we're going to create a much more hospitable environment for that grass plant to thrive. So I hope if you haven't tried it before, you'll consider some of the porous ceramic particles in your next application. And certainly if there are any questions or comments, I'm happy to field those at this time.
Well, thank you, Jeff. I appreciate all your input. I had some questions come up as you were going through and you covered them. It's really interesting and in depth. So does this have any, does the use of the Turface products have any effect on fertilization, wetting agents, or herbicides, you know, that you would incorporate along with this product?
Yeah, if I heard that right, does it have any impact on fertilization? It certainly does on fertilization because it's going to help hold on to those nutrients. We actually use our porous ceramic particles for ag chemical carriers as well. So for granular applications of pesticides, if you're doing any kind of a liquid application, yeah, the porous ceramic particles will hold onto that application and slow release it over time. Wetting agents and surfactants to a lesser degree, I would say, but certainly for any kind of insecticide and certainly for a fertilization, it is both for the sake that it's going to hold on to some of that liquid application, but as you come back in water, it's also going to hold on to that moisture so that especially if you have some kind of a slow release fertilizer or you're doing a granular, you're going to have more of that moisture held at the surface to help that fertilizer activate. Good question.
One other question. From a product content standpoint, what there is, you know, as a field and, you know, athletic field concerns, is there any safety concerns that you have with this product?
Yeah, great question. Regarding safety concerns, no, the porous ceramics that we sell and promote into sports fields are also OMRI approved as a component for organic growing. So we submitted metals analysis and all kinds of other documentation to OMRI to get that approval. The only warning label we have on the bag is a safety concern over respirable silica, and that's just something that's required from a government level that we put on there. The particle sizing that we have is too large to ever be respirable. So the warning that we put on there just says if particles are fine enough, and this is really specific to sand blasting and mining operations, but we have to put on the bag that respirable silica may cause concern, may cause respirable lung issues. Our particles are a medium-sized sand particle, is how they're classified. So it would be no different than walking on sand on a beach. So unfortunately, labeling requires us to put the warning on there, but there are no safety issues. We, in fact, I've ingested it before, not intentionally, but it happens sometimes when you're out on a field. And no harm at all, and it's safe for pets as well. We've seen it used across equine applications and horse tracks. We've seen it in backyards for dog runs, and there are no safety concerns whatsoever.
Well, not seeing any other questions at this time. I'd like to thank everyone for taking the time to join us today. Just